In this video, we are going to discuss about Git and its command like git clone, git checkout, git commit, git merge, git rebase and how this command works. If we go by definition, Git is a very efficient key value data store which thinks of data more like a stream of snapshots and has three stages, namely modified, staged and committed. It has certain data types like tree, blob, commits and tag. Tree represents hierarchical linkage. These objects contain a list of all files in the repository with a pointer to tree blob object assigned to them. Blob, it stands for binary large object. It stores the content of the file as a snapshot. Commit, it is a snapshot of the project. Tag, a tag object contains an object name, object type, tag name and name of the person who created the tag and the corresponding message. Let's understand how do we use these git commands in day-to-day project. So let's assume we have a remote branch called develop which we want to clone to our local and do some changes. For this we will use git clone command and pass the URL along with it. Here we are cloning repository of JPA auditing. The repo URL consists of hostname, username and repo name. When cloning happens, it uses repo name as folder name to copy the content from remote branch. As develop will be main source branch and multiple developers will be working simultaneously, we always create a feature branch from develop branch. So how do we create a feature branch then? We have two options. First, we can use git checkout -b destination source where -b denotes new branch creation from source branch to destination branch and it will also check out that branch in the local directory. Here we are creating a branch called feature/producer from develop branch. Second option is branch creation from git UI and checkout using git CLI. We can use git checkout to switch to newly created branch feature/producer. Now assume branch is in any ID tool like STS or IntelliJ and we are going to do some particular change to a particular file. Once change is done and saved, that file will be in the modified state. At this state, files will not be tracked. Now we want our changes to push to remote branch. So first we will use git add command. Remember here one important point. Whenever we do git add, it will not push changes to local branch directly. Doing git add, changes will go to staging area and files will be in the staged state. It will create a blob object and files will be tracked. Once you do git commit, files will be pushed to local repository and files will be in the committed state. Commit will be represented by unique ID. Let's look about commit in bit depth. Each commit has a unique ID. Each time we do commit, Git stores it as a snapshot, not as difference. For files which are not changed, Git only stores reference link to previous identical files which it has already stored. Commit has following structure. Commit 40 character checksum SHA1 hash tree reference to top level tree of a snapshot of the project at any moment. Parent, any parent commit that existing commit will hold. Author, who has committed the changes. Committer, who has committed the changes. Commit message, initial commit for JPA auditing. So let's do a quick practical. We will open the CLI, we will go to JPA auditing. So the first command I'm going to fire is git log. So on the top you can see the commit and the corresponding SHA1 has 40 character long checksum and head pointing to master. Then we have author, then we have date and at last commit message. Now I'm going to look into this commit ID. So I will fire the command git cat -file and the corresponding commit ID. If you can see, it has tree, the author and the committer and at last the commit message. I am going to deep dive into this tree structure unless I get a particular .java file. So I will again fire the same command pointing to the commit ID 4e1ac. Git cat -file, the commit ID -p. Now here you can see the blob, the tree, and again blob and the tree. And if you can see the src folder at the last, it is tree. So you can understand it is a hierarchical linkage or the folder structure at that moment. Again, I am going to that commit ID 7C092. So git cat -file-p and the commit ID. Here you can see two trees with corresponding commit ID. We will go at last till we find the particular .java file of entity. Now here you can see I am getting the folder structure and I have the entity folder. I am going inside that entity folder using the command git cat -file-p and the corresponding commit ID. Now it will show me the .java file, and if you see all of these .java file are blob objects. So it is clear now the content is stored in the blob and the hierarchical linkage is represented by the tree. Again by the same command, and you will see the whole sequence of the content starting from the import to the your entity class and the corresponding private fields. So this is how the Git stores the object in the form of object and value, where object is the commit ID, or you can say SHA1 hash, and the value is the content stored at that moment. So let's come back and see how we can reflect the changes from the local repository to the remote branch. Now we will push these files to remote branch using git push command. Commit IDs and commit message will now be reflected in remote feature branch. If multiple people are working on same feature branch, we will require to take their changes also before we commit. For this, we will use git pull command. It performs two operations internally. One is git fetch, which will pull all latest changes, and other is git merge, which will merge latest changes to local repository. And believe me, this is one of the popular interview questions at junior developer level. We can use either git merge or git rebase to sync feature branch changes to develop branch. If changed files are different in feature branch and develop branch, then there will be no conflict and merge will be successful. But if same file has been changed in feature branch and develop branch, then there will be conflict and merge cannot happen unless conflict is manually resolved. So how conflicts are represented in the file? Conflicts are represented like this structure, where content between these two symbols is conflicting content from the receiver branch or the branch which is going to receive the changes, which is develop here. Content between these two symbols represent content coming from the feature branch or merging branch. We need to manually resolve this, which content to carry forward and persist. This was all about this video.